Hello class. Today we're gonna our first day to do our online teaching. I try to make this as close to the classroom setting as possible. So I found my daughter's a little whiteboard, so I'm gonna use it. Hopefully you guys like it. If any question relate to the lesson, the lecture I give out, and then your homework question, feel free to post on the discussion board. I will gather all the questions and I will answer it in the video. Okay, today we're going to do these lessons for March 17th. Today's lesson, okay, I will upload both of them. And 7.3, trigonometric substitution. And I want to give you the patterns possible, okay? So these are the formula for the patterns. First formula is 1 minus sine squared equal cosine. Okay, cosine x, and then 1 minus the cosine x squared equal to sine x. The second pattern is 1 plus tangent squared x equal to secant x. The third is secant x squared minus 1 equal to tangent x. So our trigonometric substitution will require these three patterns here. They're using these three patterns formula. I want to remind you that when we learn 5.5 use up, okay, if we have an x here outside and then inside the 4 minus x squared or any number minus x squared, we can use a u sub by letting u equal to this. Okay, that's our u. So we said that's our u. And then we can integrate the problems. But if I take away the x here, so I have no more x here, then you cannot use a u sub because you don't have any x outside. In this case, we have to use a trig sub. So we look at it, okay? We look at the pattern here. We look at these problems. We want to see that which pattern this problem looks like, okay? This is 4 minus x squared, so looks very much like this one, but it's not exactly. So what do we need to do, okay? So for this problem, let's say, our goal is to make this to be 1. So how should I do that? So I'm going to factor out the 4. So I factor the 4. So I factor the 4 outside. And then I will have a 1 minus the x squared over 4 dx. Okay, so once I factor out the 4, that's what I get. So this one factor out the 4. I don't have 4 here, so I end up divide 4. So that becomes 2. And then I write this as x over 2 squared. I want to write very close to like this pattern, okay? So then I can use this one to substitute for either sine or cosine. So I'm going to let x over 2 equal to sine x. Okay, I'm going to take the first one, you can either take the second one, that's fine. And then I'm going to time by 2 on both sides. Oh, sorry, I forgot time by 2. Okay, then I need to change everything in terms of that. So therefore, I'm going to take dx. Or you know what, I'm going to use a theta because of x here, so I'm going to use a theta here. So just to separate that difference, okay? And so now I'm going to go dx equal to, take the derivative sine is equal cosine theta d theta. So I'm going to replace everything in terms of theta, okay? So if you want to, you can change it to theta. That way you won't confuse. This is all theta here. And so you can do that. So now I'm going to replace everything in terms of theta. So I'm going to continue here. So that's equal to 2 times, okay? Now that becomes 1 minus, because my x over 2 equals sine theta. So it becomes sine squared theta. And then my dx is equal to 2 cosine theta d theta. So 2 cosine theta, oh, I'm sorry, I don't have enough room here. Or you can just come out directly. This is just a cosine theta. So that's I put the 2 in 2, so the 4 cosine theta, and then I still have a cosine theta here, and then d theta. So now I have 4 cosine squared theta d theta. Now for this, you cannot integrate cosine square, so we use the technique we learned before in 7.2. We said that cosine 2 theta equal to 2 cosine squared theta minus 1. Okay, I'm going to solve this one out. So cosine squared theta equal to 1 plus cosine 2 theta over 2. Okay, so I'm going to place this one in here. Okay, so I'm going to continue. So that's equal to 4, and then I take out the 2, 1/2 here. Okay, take out the 1/2. I will have a 1 plus a cosine 2 theta d theta. And then that just equal to this reduced, so become 2, and that's the theta here. Okay, theta. And I remember this is just what? 1/2 sine 2 theta and plus c. Okay, and you can multiply it out if you want. That will be up to you. Okay, because c is arbitrary, you put it inside, outside, doesn't make any difference. So that's how you do for trig sub. Okay, so you look for the pattern. Okay, I change everything to theta so that we won't confuse the x here. Now we're going to do I'm going to leave the pattern on the top. So now we're going to do some exercise from your class. So your book. So that I couldn't find a big whiteboard on time, so I just had to use the smaller one. And to tell you, I went to look, and all the stores sold out all the whiteboard. So I used my daughter's, the small one. Let's look at problem number 8 from your book. By the way, I miss you guys, and then hopefully I can get to see you guys again soon. So t squared minus 16, and I just want to tell you that a lot of students do very well in the exam. Okay, the test number 1. So this is problem number 8. Okay, so what we need to do is we decide which pattern first. Okay, which pattern looks like this one. So this one's a variable go first. We look at it. Okay, variable go first. This one. This only one the variable go first. So secant squared theta minus 1. The theta is the variable. Okay. So, but it's not exactly, because this is 1 here, this is 16. So we're going to factor out the 16. So when the 16 factor out become 1 over 4. So I'm going to just 1 over 4 here. So dt over t squared. And after I take out the 16, so these become t over 4 squared subtract 1. Now it looks a little bit closer like this one now. So we're going to let this one equal to secant theta. Okay, and then we're going to solve for t. Okay, now we need to change everything need to change in terms of theta, so we change this one also. So take the derivative dt, it gives you 4 secant theta, derivative secant theta is equal to what? Secant 10. Okay, now put everything inside here, so everything in t need to change. So that become 1/4. Okay, your dt is equal to that. Over your t is equal to this one, so become t squared, so it's 16 secant squared theta. This one just equal to tangent theta. Okay, tangent theta, and you don't have to show me the work because I give that to you, you know just that's equal to. So after that, we're going to reduce, okay? Reduce. This one take away 1. This one's a 4. And guess what? There's a 4 here also, so that can also reduce. So that becomes, oh no, I'm sorry, this cannot reduce. This is in the denominator. Sorry about that. So that actually comes out as 1 over 16 because this is not on the top. So 1 over 16 and then 1 over secant square, 1 over secant theta, sorry, couldn't even talk. 1 over secant theta and then d theta. And that's equal 1 over 16. Secant is equal to cosine theta, d theta. Now I just need to integrate that one, so that becomes 1 over 16 sine theta plus c. Okay? Now that's not finished yet. How come? Because what you're given the problem is in terms of t, not in terms of theta. So you got to do something about it. You got to change your sine theta. So you use this one, okay? Your t over 4 is equal to secant theta. So from here, you change this to convert to 1 over cosine. So that means the cosine theta is equal to 4 over t. Okay, you don't need to flip this one, just flip this one. Okay, so cosine theta is 1 over 4 over t. Now remember this is from trigonometry we learned. So this is my theta here. Cosine theta equal to adjacent to hypotenuse. So this is 4 and t. And this will becomes t squared minus 16. Okay. Now sine theta is equal to opposite to what? Hypotenuse. Oh, over 4 over t. And you put this one in here. Okay. So your final answer is 1 over 16 t squared minus 16 over t and then plus c. So that's your final answer. Okay, that's how you do the problem. And if there's any part you feel confused, you make a mark on it and then I will explain it in the video. Okay, the next video. If you have any question, feel free. And I know that because not in the classroom, you couldn't answer me right away. I know that, you know, this is a tough time for you to try to figure out, you know, by watching my video with my accent, my English a little bit comes out of videos, audio doesn't sound too clear sometimes. So try to understand math and understand me. So if you have any question, feel free, okay? I will definitely answer your question, so don't worry about it. The next problem I want to do is number 10. Number 10, we have 0 to 2/3, and then 4 minus 9x squared and dx. So we're going to do the same thing. We said, okay, how should I make this looks like any one of them? So you can look at here. A number subtract a variable, okay? So number subtract a variable. So you can use this one or this one. This is adding. This is a variable subtract, so it's not going to work. So it has to be pattern number 1. So we do the same thing. We want to make this to be 1, okay? So the first thing we should do is to take out the 4, like how we did earlier. When the 4 takes out, become 2. And then this one, don't write it because you're not going to use it until the end. So there's no need to keep carrying through, okay? So just go 1 minus, now the 4 comes out, become 2, so this become 1. And then make this to be 3x over 2 squared, okay? That's basically the same way to do it every time. And then now you can see looks like that now, okay? So we're going to let this to be sine. Okay, So we have a 3x over 2 equal to sine theta. And then solve for x, so x equal 2/3 sine theta. And then now take the derivative. So dx equal to 2/3 cosine theta d theta. Okay? And then now this put everything inside there, so that becomes a 2. And we know that that comes out to be equal to cosine theta, is that right? So this one, you don't need to do anything, okay? Just equal to cosine theta, okay? So that be cosine theta. And the dx, now the dx here is equal to this one. Okay, put it inside here. And then times by 2/3 cosine theta d theta. So simplify this, take out sine, so that becomes 4/3 cosine squared theta d theta. And then once we get to here now, remember this one that we did earlier, cosine squared theta, okay, maybe I write right here, cosine squared theta equal 1/2 1 plus cosine 2 theta. That's the formula. And use it. And then we replace it here. So I'm going to take out the 1/2. And that will be 1 plus cosine 2 theta. Sorry about the writing here. It's just really hard to write, so small. And then 2 rho d theta. Okay? And then after that, I'm going to continue here. Okay, so this is for the formula. And then this part go up here, so that's equal to 2/3. So I'm going to continue here, okay? This is continue here. Equal 2/3. And this is integrate 1 just equal, with respect to theta, just equal to theta. And this is a, remember I told you guys, this is just a 1/2, okay? To theta. Now, don't put the plus c because you're doing the limit. The next thing is you're going to convert this to x first before you substitute the 2/3 inside. And then so we're going to do our little formula. Because we are told that sine theta equal to 3x over 2. So this is theta here. And sine is equal to what? Opposite to what? Opposite to what? Hypotenuse. So this is 2, 3x. I just remember my first problem I did, I forgot to convert back. The first one, the 4 minus x squared. So I apologize, I didn't finish that problem. So, but anyway, you have to convert back. And then we are looking for sine 2 theta, okay? Okay, so now there's another identity here. Okay, I'm going to erase this one first. I need some more room. Sine 2 theta equal to 2 sine theta cosine theta. That's another trig identity. So that means I need to find this one and I need to find this one. And so what I'm going to do is that I said, okay, so sine 2 theta, sine theta, I need to know sine theta. I need to know cosine theta, so I need to know this one. This will be 2 squared minus 3 squared, so it's 4 subtract 9x squared. Okay, so now I'm going to go cosine theta equal to adjacent to hypotenuse. Now it's a square over 2. So I put it inside. I put it more room, so I have to, sorry about that, I might have to erase this part because I don't have enough room to finish these problems. So I continue here, so that's equal to 2/3. And then your theta equal tangent, just equal to what? I have earlier was a sine, I erased that part, okay? I have a sine theta equal to 3x over 2. So theta just equal to sine inverse 3x over 2 for this one. And then plus 1/2 plus 1/2, and then sine times 2 sine theta cosine theta. So sine theta equal to 3x over 2, cosine theta equal to that. So I use the identity formula. Okay, and then the limit is from 0 to 2/3. Now I'm going to put it inside here. So 2/3 sine inverse 3 over 2 times by 2 over 3. Okay, x equal 2 over 3. And this is reduced here. Plus 3 over 2 times by 2 over 3. Same thing. And times by 4 minus 9 times by 4 over 9. This is a x squared, that's 4 over 9 over 2. And then for the 0, I don't need to worry about it because it's a 0, 0, so all 0. So I don't need to substitute the 0 inside. So that reduced, so that becomes 2/3 sine inverse 1 plus that reduce, and then this is reduced here. This is 4 minus 4 just 0, so this is a 0. So that becomes 2/3 sine inverse 1. Sine graph is like this. Sine inverse 1 is this is power 2, so this is times by power 2. Reduce that, so the answer is equal power 3. Okay, I know this one's a little bit long. It takes a lot of patience to do problem like this. Okay, so just be patient with it. If you have any question, feel free to ask me. And let's look at problem number 14. And some simple said, can I convert the limit first? Convert the limit the 0 to 2/3 to angle. You can do that also, okay? That sometimes it actually make it faster. So maybe later on I can make a video just for that problem again. The one I just did. Number 14. If a lot of students have problem with it, I will make a video again on just on that problem. 0 to 1. Dx over x squared plus 1 squared. So you look at this one, and then you look at the pattern first. You look at it, which one is a plus? Plus is only one, which is the pattern number 2. This only one is a plus. So we're going to, this will be my tangent now. Okay? My tangent theta. So x equal to tangent theta. And dx equal to tangent is secant square theta d theta. And now we're going to substitute everything inside. And so that becomes, don't write the limit yet. Okay, dx equals secant square theta d theta. Over, this is x squared plus 1, so that's a tangent squared plus 1, so that's a secant to the 4th, secant 4 theta. We got x squared plus 1 equals secant squared, so secant squared to square again, so secant to 4. And you can see this is reduced. Take away, so become 2. So that becomes d theta over secant squared theta. Now secant squared is equal to what? 1 over cosine, so this just equal to cosine squared theta d theta. And then That's easy again because that's the formula we have earlier. So that's equal 1/2 1 plus the cosine 2 theta d theta. So that becomes, so I'm going to continue here. That becomes a 1/2 theta plus, so this one's the same thing again, 1/2 of sine 2 theta. So we can just memorize the pattern. Now, this is sine 2 theta, it happens again, so it's a 1/2 theta plus, use identity, so it's a 1/2 times by 2 sine theta cosine theta. Okay, reduce that, so that becomes 1/2 theta plus sine theta cosine theta. Now we just need to find out what's this equal to. Actually, this is one more step. So this is tangent theta equal x. So theta equal tangent inverse x. So tangent inverse x plus this one, we can use a little triangle, okay? And that's my theta here. So tangent theta equal to what? Opposite to adjacent, so that tangent theta equal x, so this is x and 1. And that will be 1 squared plus x squared. Okay, because tangent theta equal to, oh, I'm sorry. Yeah, tangent theta equal to x. And so from this little triangle, I know sine theta equal to opposite to hypotenuse. And cosine theta equal to, I'm going to write underneath, adjacent to hypotenuse. And then everything's go from 0 to 1. Okay, so now put it inside, so it's a 1/2 tangent inverse 1 plus 1 go inside here, this is a 1, so 1 divided by square root 2, and this is a 1 divided by square root 2 also. And for 0, this is a 2, I'm sorry, this is 2. And then the 0 go inside, everything's at 0, so I don't need to worry about that. So my answer is 1/2 tangent inverse 1 is the power 4 plus this multiplies 1/2. So your answer becomes power 8 plus 1/4. Okay, so that's for number 14. And if you have any question, like I said, and feel free to ask me, okay? So that's for, now if you said that, can I convert this one to theta? Okay, you can, okay? I show you how to do it. So if you're going to convert this to theta, then you don't need to do this part. Okay, I'm going to show it to you. Okay, I'm going to erase this one and show you another way to look at these problems just at the end here. Okay, because it's a limit problem, so it's kind of nice. Once you get once you integrate, I forget that you still have to do the integration. Okay, that's all we have earlier, right? So once you get to here, you look at this, okay? Because we are given tangent theta equal to x, okay? My x is from 0 to 1. So I'm going to go x equals 0 first, okay? Then my tangent theta equal to 0. So that means theta is equal to 0. That right? And then so this from here is, I'm going to use a new method, okay? From here, the second way to do the problems, just for the limit part. And then when x equal to 1, okay? And then tangent theta will equal to 1. That right? And so theta equal to what? Power 4. Okay? So now you're gonna, so means your theta is gonna go from 0 to power 4. So you put it right here. So from here, I'm gonna do it right here. So 1/2 theta plus 1/2 of sine 2 theta from 0 to power 4. My new limit. And so I substitute inside, so it's a 1/2, and this is a power 4, plus 1/2 of sine 2 times the power 4. And 0 go inside to the 0. And then you can see that there's a power 2 here. So this is a 1/2 power 4 plus sine power 2 is equal to 1. So just 1/2. And so we get the same answer, power 8 plus 1/4. So whichever method you like, okay, use it. This is probably a little bit easier, I think, okay, for when a problem has a limit. When a problem has a limit, I feel like it's a little bit easier to do it like that, but then your trigonometry should be pretty clean, okay? You know exactly what to substitute, convert this, okay? So that's for number 14. And then I want to supplement a problem that that we don't have in the textbook. I want to do one more problem. This problem will help you for problem number 13 in your homework. Okay. This is for homework number 13. We will help you for number 13. So here's the problem. Okay, class example. And the problem is dt, integrate dt over t squared minus 6t plus 13. So this one, nothing like this here, right? This is a no square here, just this one square, but doesn't mean anything. So you need to make it to be something square and then plus 1 or 1 minus. So we're going to use a technique, it's called completing the square, that we learned in Math 35. So what we do is that we said, okay, I'm going to complete this as square, okay? So I'm going to do it outside. So I say, okay, t squared minus 6t plus 13. I want to know if I can make something like looks like any of this. So I'm going to, that's equal to t squared minus 6t. I need to add something here, okay? I'm going to add what? Half of 6, so that's a 3 squared. And I need to, because I add something, I need to subtract that also. You cannot add something and not subtract it, then you change the problems. So plus 13. So this is 3 here will become t minus 3 squared, okay? And this is a minus 9 plus 13. So that becomes t minus 3 squared plus 4. Is that right? Okay. Now you're going to put this one inside here. Okay.